Assalamualaikum warahmatullahi wabarakatuh. So today we're going to present about Hecras simulation of Sungai Johor Tributary. Before we start our presentation, let me introduce our group members, which is me, Afian bin Syaiful, Saril Anin Hading, and Danisa Kumar. This presented to Dr. Muhammad Salahuddin bin Adnan, Lecturer of Civil Engineering Software. My part, I will introduce about introduction. Hecras is a computer software that stimulates the flow of water in natural river and other channels. This program has been revised by the manufacturer from the time to time to make it more user-friendly. It has been updated from one-dimensional modeling analysis to two-dimensional modeling analysis with flow and sediment transport modeling for capabilities. For your information, this is the US Army Corps of Engineers created this program to control the waterways, harbors and other public works under their authority. Our project goal is to create a model for an earth drain that connects to Sungai Johor. The river is an example of non-prismatic channel, which are naturally occurring channel of varying cross-sections. This kind of mobile boundary channel has boundaries that deform as a result of the flow's continuous erosion and deposition. Because of the higher rainfall rate and the natural geological of the river section, floods are found in this area. The problem statement of our study is the floods are happening in an increasing rate in Sungai Johor, Malaysia. When the rainy season arrives, the water level will rise at an alarming rate, resulting in flooding and damaging the properties in surrounding area. Observations show that the earth drainage connected to Sungai Johor Tributary needs some modification in terms of depth and width of the drain depending on the location and the water flow. The objective of this study is to analyze the effectiveness of the current drainage from any flood in 5 years to 50 years to come, which is exactly is 5 years, 20 years and 50 years to come. Provide suggestion using Hecras to solve flood by section modification and to choose a correct mean value, slope, width and depth of the channel for different class and land cover. The study area of this study is Sungai Johor. The largest river in the Malaysian state of Johor is the Sungai Johor. The river flow is an approximately north to south directions, originating from Mount Gemuruh and empties into the Strait of Johor. It is 122.7 km long and has a catchment area of 2,636 km square.
A very good day everyone, I am Danisa Kumang Anarone and I'm going to explain on my part, which is literature review. In this project we are going to use Hecras software in order to calculate the water surface profiles. Generally, Hecras software has several functions which are to perform one-dimensional steady flow calculations, to perform 1 and 2-dimensional unsteady flow calculations, computations of sediment transport or mobile bed, and modeling for water temperature and water quality. There are a few assumptions that need to be made when using the software, such as dominant velocity is in the flow directions, streamlines are practically parallel and therefore hydrostatic pressure distributions prevails over channel sections, and last but not least is hydraulic characteristics of flow remain constant for the time interval under consideration. So in our projects, we are going to use the steady flow water surface profiles. It used for steady gradually varied flow and able to model subcritical, supercritical and mixed flow regimes water surface profiles, and it also able to handle full network of channels, a dendritic system or a single river ridge, and it use basic computational procedure based on the solutions of the one-dimensional energy equations as shown in the screens. Okay, next, the case study. A study was conducted by Breck in 2002 at Montana State University. In this case study, Breck used Hecras software to calculate water surface elevations in minder bands incorporating band waivers. The data gathered from Highwood Creek watersheds located in central Montana east of Great Falls. The flat vary gradient and coarse sediments deposit fill the existing channels and causing the streams to move laterally. In order to solve these problems, stream restorations and bank stabilization techniques were carried out. Here we move to the next part, which is methodology. And in methodologies, there's a few steps in modeling the water surface profiles, which is the first step is to create new project in Hecras, and the second is to define study area, which is Sungai Johor tributaries. The third step is to collect all the data required, but in these projects the data were given to us, and the next one is to export the obtained data in Hecras model, which is include the computations of all the data. And then the next one is to create a model in Hecras. And then the sixth step is run the model using different steady flow in frequency analysis of 5 years, 20 years, and 50 years. And the next one is to flood simulations using Hecras. And then the next one is post-processing spatial data by channel modifications, and last but not least, data analysis. This is the steps in modeling the river using Hecras. As usual, we start from Hecras, start the Hecras and click File and New Project, and then enter project title and click OK. The sixth step is to enter the geometric data. First one is for river system schematic. It is drawn from upstreams to downstreams, and river stations number increases upstream. The second one is cross-section data. Okay, the next step is to enter steady flow data, which is include the profile, the flow data, and also the boundary conditions. Next one is to perform steady flow simulations, as you can see here. And the last step is to view result, which is the cross sections plot, profile plots, and 3D multiple cross sections plot, and X, Y, Z perspective plot, and profile output table. Okay, this is all from me. Thank you.
Hi, my name is Saril Anin Lading, and I will explain about our project's results. Our group river profile contained 9 chainage. As you can see here, it started with upstream chainage 1277.5, going down to chainage 1100, chainage 950, chainage 800, chainage 700, chainage 400, chainage 150, chainage 50, and lastly to chainage 0, which is the downstream. The discharge value at the chainage, some of it will be the same, and some of it will be different. As you can see on this right side, the discharge at the chainage will be based on 5, 20, and 50 years. From here also we can see the upstream of the river will have the lower discharge value, because the flow starts slow from the top and going down faster with a bigger value. Next, after we analyzing the geometric data given, the simulation ended with 2 results. The first one is before the modification, and then the second one is after the modification. As you can see here, this is the chainage 0, and we can see the cross section is not overflowed, so we do not need to modify it, so it is maintained. The cross section is maintained. Same goes to chainage 50, where the water inside this channel is not overflowed, so we can maintain it like this, so we do not need the modification. For channel 150, in 50 years we can see the water was overflowed inside this channel, so as an engineer we need to overcome this situation by modifying the cross section of the channel. So in Hecras, we use the template design to modify by using this following data with a depth of 5 meter, width of 8 meter, side slope of 0.1 and Manning's n value 0.02. And then after the modification, the channel will look like this. Same goes to channel 400, where the water in this channel is overflowed, so we need to modify it with this data. The depth will be 4.2 meter, the width will be 10 meter, the side slope will be 0.1 and the Manning's n value will be 0.02. So after the modification, the new cross section of the channel will look like this. The channel 700 also experienced the overflow of the water inside the channel, so we need to modify the cross section by using the following data, which is 4.2 meter in depth, 15 meter in width, 0.1 in side slope and 0.04 for Manning's n value. Same goes to the channel 800, where the water is overflowed inside this channel. Then we need to modify the cross section of the channel with the data of 6.5 meter, 14 meter of width, side slope of 0.1 and Manning's n value of 0.04. And then after the modification, the channel will be look like this. For channel 950, the channel also experienced overflow of water, as you can see here, and then we need to modify it with a new cross section with a depth of 5 meter, width of 16 meter, side slope of 0.1 and Manning's n value of 0.04. So after the modification, the new cross section will look like this. Same goes to channel 1100, where the water inside this channel it was overflowed, so we need to modify it with a new sets of data, 5 meter of depth, 12 meter of the width, 0.1 side slope and the Manning's n value of 0.04. And then the water inside the new cross section will not be overflowed. Lastly is the channel 1277.5. As you can see here, the water is not overflowed in this channel, but we need to consider to modify it as well. So with the new data, the depth will be 6 meter, the width will be 20 meter, the side slope will be 0.1 and Manning's n value remain the same, 0.04. And then the new cross section will be look like this. As for the conclusion, a flood is something that we cannot control because it is an overflow of water when it exceeds the riverbanks as the flow rate exceeds the capacity of river channel. So what we can control is the river cross section. This is because Hecras software they can forecast those situations, not only because it is a one-dimensional steady flow hydraulic model design, but also to help engineers in channel the flow analysis and also the flood plan determination. Last but not least, in Sungai Johor tributaries, which have the total of 9 channels. 6 of them are overflowed and 1 almost overflowed. So 7 of the channels were modified and able to accommodate the discharge flow safely without occurrence of inundation in the next upcoming 5, 20, and 50 years. Thank you.